In this video, we would like to present our investigations into the uncertainty-driven exploration strategies for online continual learning in the robot bin picking task. We first initialize a reinforcement learning benchmark for robot manipulation, namely COMSEC, with a small-scale dataset. After that, we train the network continuously through a limited number of real-world interactions with the novel objects while ensuring their generalization ability to them. We investigated the uncertainty estimations in the critic networks, including Bayesian uncertainty estimation and quantile regression, which are successfully embedded in the COMSEC architecture and integrated into the exploration strategies through the Gaussian UCB approach. Our experiments demonstrate the efficiency of uncertainty-driven explorations and further verify the superiority of epistemic uncertainty over the aleatoric uncertainty, as was proven in previous works. In addition, as inspired by APEX, we built a multi-process training schedule for efficient learning as well. Our value-based uncertainty estimation relies on the following two paradigms. The first approach modeled the final Q estimates as Gaussian likelihood, and another one stems from distributional reinforcement learning. By applying Q ensemble in both methods, the aleatoric and epistemic uncertainty can be well modeled and disentangled. Here we modify the critic network through the integration of uncertainty estimation as mentioned above. Fed by RGBD images, we observe the concentration of aleatoric high uncertain area on the boundary of objects, while the epistemic one shows few highlights over the whole Q map in the source domain sceneries after offline training of probabilistic COMSECs. We built a multi-process training schedule for efficient learning inspired by APEX. Each group of agents from the whole ensemble are updated in individual training processes. In the inference process, the data collection is served by the real-world robot bin picking. Exploration is executed through the heuristic search over the whole UCB map, which equals the summation of Q map and discounted uncertainty map. Throughout the whole experiment, we applied the 7DoF robot with stereo camera for data collection, exploration, and performance evaluation. The objects that serve the offline data collection involves regular and opaque items, while the online objects are characterized by complex structures and transparent surfaces, for instance. We aim to evaluate the generalization ability and the efficiency of our strategy by analyzing the grasp success rate. Through various ablations on the uncertainties type, learning steps, and several hyperparameters, we are convinced that the uncertainty-based exploration generalizes better to new objects and collects valuable online transitions in the long run. We report a growth of 15% on the success rate compared to the COMSEC baseline in average and a further increase of 6% while explored on the epistemic uncertainty only.